For lesson 8-5C, we're going to look at literal equations. Now this is a supplemental lesson, so it cannot be found in your book anywhere. So it means there won't be any online tutorials for this other than this video. So if you don't understand or are having trouble with this lesson, it's really important that you ask or rewatch this video. So for the key terms here, what is a literal equation? It is a formula or equation that involves several variables. And what we're going to do is we're going to solve the following literal equations for the indicated variables. So in example 1, this is a pretty standard formula here for area. Area equals base times height. So there are 3 variables in this equation with no numbers. So we're actually going to solve this equation or this formula in terms of h. So I don't want to solve right now, it's being solved for area, we want to solve it for height. So it's really important that you understand your basic principles of algebra in order to be able to work backwards without having numbers in front of you. So if we want to solve for h and get h by itself, we need to get rid of this b. Well, what is b? Essentially, it is the coefficient of h. They are being multiplied together. So if I rewrite this a equals base times height, I need to divide both sides by b in order to cancel b and get rid of it, because b divided by b, no matter what that number is, it's going to cancel. And as long as we do the same thing to both sides, the equation will remain equal. So h, which is height, equals a divided by b, which is the area divided by the base. Okay, and that's actually going to be our answer. So it seems kind of awkward because we're solving for an expression, but that is what we're looking at, and that's what we're talking about here. We're solving literal equations. Why it's important to be able to do this is because if you're given 3 numbers, an area, a base, and a height, and you're given area and the base, but you're looking for the height, it would be helpful for you if you could actually set the formula up to solve for what you're looking for rather than plug your numbers in and then work backwards to solve. If you can already flip these numbers and this formula into a formula that you can use to solve for what you need, it's going to be a lot quicker for you. So let's take a look at example 2. Distance equals rate times time. That's what d equals rt stands for. We want to solve for r. So that means we want to get r by itself. So d equals r times t. So then this is multiplication. We need to divide by t, because we want r by itself. So when we divide by t, we get rid of it. Now whatever we do with one side, we have to do to the other to keep the equation equal. So what I'm left with is r equals d divided by t. And what that stands for is distance divided by time gives us our rate. So that's like miles per hour or meters per second or something like that. We got to know how far we're going, like miles, and divide it by time, and that gives us miles per hour. Alright, so this is another common formula for circumference. Circumference equals 2 pi r. We want to solve it for r. So we need to look at the coefficient. Okay, this is all multiplication, so let's just go ahead. C equals 2 pi r. I'm going to divide by 2 pi. Okay, I could divide by pi and then divide by 2 and do it in separate steps, but I need to think of this as one big coefficient. I need to get rid of the whole thing. So go ahead and divide by 2 pi on this side. The 2 pi's cancel, so I'm left with r equals circumference divided by 2 pi. Okay, and so that's how you would find the radius. Given this formula, c equals 2 pi r, you can set the formula up to solve for radius if you know what circumference is. All right, example 4, we want to solve for m. It's important that what we're trying to get by itself, I see that m is right here, so I have a whole bunch of things going on. I'm going to rewrite this because I write a little bit bigger than this typed print. So 3 plus negative 3n equals 8. Notice I changed this to addition when I rewrote it, and that's fine if you want to do that. Now think about your fundamentals of algebra. Okay, this is what we're trying to get by itself. So that's what I'm going to focus on. So I'm going to treat this as the coefficient and this as my variable. Okay, and then this is actually addition, and I need to treat this like a normal constant. Even though I see a variable here, this is all one number, and that's what I need to treat it like. Even though I don't know what the number is, treat it like one quantity itself. So right now it's a negative 3n. I need to get rid of it. So I need to add 3n to both sides. All right, so when I do that, this whole thing is 0, which is what I like to see. So I get 4m, and that equals 3n plus 8. Now, I always like to kind of have my variable expression in the front, so I know usually we like to keep everything in order, and here I actually move the 8 to over here, but traditionally we like to have the variable expression in the beginning of our algebraic expression. So now, when I look at this 4m, how do I get rid of this 4? Well, I have to divide by 4. And whatever I do to one side, I have to do to the other. So I can divide this whole thing by 4, or you could think of it as 3n divided by 4 plus 8 divided by 4. And actually, we can simplify a little bit further if we think of it that way. So I'm going to erase this for now, and we'll get to that in a second. So the 4's will cancel, and I'm going to get m equals 3n plus 8. Okay, and again, we can think of the whole thing being as divided by 4, or I can write divided by 4 divided by 4. Now, if I do this, I can actually simplify this thing right here, because 8 divided by 4 is 2. So I can write m equals 3n divided by 4 plus 2. Or I could actually write this part here, it could be 3n divided by 4 also is 3/4 n. That's the same thing. So whether you want to write it like this, 3n as a numerator divided by 4, or 3/4 n, that doesn't matter. But if you leave it as 3n plus 8 all over 4, notice you can actually simplify that a little bit further, and we want to do that. We want to simplify solving for m as much as we can and get rid of as much as that denominator as we can, so that way we don't have to divide later. We can just put in n and solve for it, and we have our answer as quickly as we can. All right, so now we want to solve for k. All right, so let's rewrite this. K plus negative 2 all over 5 equals 11j. All right, notice again I changed it to addition. Okay, first things first, I need to get k by itself. So remember, we have invisible parentheses up here. So normally we would get rid of the addition and subtraction before multiplication division, but since it's written like this, we're actually going to multiply by 5 on both sides. Over here I'll write it as a fraction because it's written as a fraction. Over here I can just write times 5. All right, the 5's are going to cancel on this side, so I'm going to be left with k plus negative 2 equals, now I can actually multiply this together. That's fine. I can go 55j because multiplication is commutative. I can multiply the 5 and the 11 before the j. Now I need to get rid of this negative 2, so I'm going to add 2 to both sides. All right, and so that's going to be gone. So k is equal to 55j plus 2. All right, so this would be our way to solve this equation for k. Notice we don't actually have an answer. We're just setting up to solve for a different letter. All right, in example 6, we want to solve for t. So again, we're working on getting t by itself. So 28 equals t times r plus 4. Let's get rid of this constant first. So we're going to subtract 4 on both sides. All right, so we get t times r equals 24. Now again, we're trying to get t by itself, so I need to divide by r on both sides in order to cancel the r's, and so t equals 24r. Now I don't know what r is, so I'm done right there. As soon as I know what r is, I can plug it in and find t, and that's the whole purpose here. We're trying to set it up to solve for t. All right, 2 more examples left. This one we're going to solve for y. So we're trying to get this part right here by itself. So x plus negative 2/3 y equals 12. Notice I changed the subtraction to addition. All right, so again, we're thinking of this x as a quantity. And right now it is a constant, even though we don't know what it is. Yes, it is a variable, but we need to treat it like a constant. So we need to get rid of the x on both on this left side. So subtract x from both sides, and what I'm going to have here is just 0. So I'm going to be left with negative 2/3 y equals negative x plus 12. Again, notice I put the variable expression in the beginning. Now I need to get rid of this negative 2/3. Okay, this is multiplication, so normally I would divide by whatever the coefficient is. But remember, we don't divide by fractions, so I'm going to multiply by the reciprocal. And the reciprocal would be negative 3/2. All right, and so I need to multiply both sides by negative 3/2. So what I'm going to do here is I'm going to actually put parentheses around this, and I'm going to multiply by negative 3/2. All right, let's move this over just a little bit. So your 3's are going to cancel, your 2's are going to cancel, your negatives will cancel, and you're left with y. All right, now here, this is just a distributive property. So let's go, negative times a negative is a positive. So I'm going to write 3/2 x. All right, now we got rid of the negative sign. Now, 12 times 2, okay, 12 times negative 3/2, I know I'm going to get a plus negative, okay? I know it's going to be negative because it's a positive times a negative. The 12 and the 2 can simplify because 12 can be 12 over 1. The 12 is going to be a 6, and the 2 is going to be a 1. And then so I can do 6 times negative 3, which is negative 18. So this would be in simplest form solving this equation, or this literal equation, for in terms of y. So we're not actually solving it, we're just getting ready to solve it for y. As soon as we find out what x is, we can plug it in and find y. All right, for our last example for today, we have the letter q. That's what we want to solve for. So a times q plus negative 8 equals 23. Again, notice I changed the subtraction to addition. I want to get q by itself, so first I need to get rid of this constant, so add 8 to both sides. All right, so I have a times q equal to 31. Go ahead and divide by the coefficient of a, because we're trying to get q by itself. A's will cancel, so I'm left with q equals 31 divided by a. And that's as far as we can go with that problem. And that'll be also our last example for today. If you have any questions with this, it's really important that you maybe re-watch this video. You're also going to get a worksheet for today's lesson, so be sure to check the answer key that I will post to Moodle.